Ich schalte mal um, oder?
Mhm, okay. Ja. Passt. Gib mal Turn.
Muss jetzt alle ein bisschen tiefer fliegen.
Dom here from Essential RC. What you have just watched is a demonstration of a prototype thrust vectored Vtol capable trijet created by my friends Dietmar and Chris, who are joining me on video conference from Germany today. Now, I met Dietmar and Chris at the Hobby Model Spiel trade fair back in 2019, where they were part of the DMFV display team, who were all demonstrating some amazing creations. These guys are truly some of the most innovative aero modelers I've ever met. So what did they demonstrate there? They demonstrated the Star Wars pod racers, Harry Potter on his broomstick battling the dragon, Santa on his sleigh being pulled by reindeer, and some flying trains. These guys are so innovative, it's just amazing. So what Dietmar sent me, and Chris sent me a few weeks ago, was a video of this amazing Vtol concept that we've just shown you. And I said, people who watch this are not just going to be happy seeing it fly. They're going to want to know how you put this thing together. And they kindly agreed to do that. Hi guys, how are you?
Yeah, hi, hello.
Thanks for joining us today. I see you've got the Star Wars pod races behind you.
Yes, yes.
We love those, and people love watching that video on the Essential RC YouTube channel. So thanks for joining us today. So I guess the first question would be, what was the inspiration for the trijet that we've just seen flying?
Yeah, as we look always for new challenges together after an exhibition, because after the exhibition, normally it's before an exhibition. I mean, in this case, we have a bit more time, unfortunately, but we hope we will have a new exhibition soon. So yes. The question is what to build. And I was always thinking, after programming the pod racers, build something with a thrust vectored control airplane. I mean, I was thinking of building the SpaceX rocket.
Like the Starship, yeah?
The Starship, which is doing flight tests right now, because I'm really impressed of this thrust vectored control when you move the rocket around and you land and start and so on.
We just saw that yesterday, actually. People will be watching this, and it will have happened a few days ago, I suspect. But that was amazing, wasn't it?
Yeah.
Really good.
Amazing achievement in space travel. So yes, I can imagine that being inspiration. So
exactly.
Sorry, back to the trijet then.
Yes.
That was the inspiration. But also you were saying it was a concept from Lucasfilm, kind of a Star Wars concept, was also
in a joint
inspiration for this.
Yeah, in a joint venture with Porsche. So they did a pretty nice design and a nice Starship, which as model enthusiasts, we really like how it flies in this video. And as we also like building scale planes, because everything you mentioned is a scale build, so there's a one-to-one in the real world.
Like a scale model,
yeah, maybe not in the films like the pod racers, but we think it's real, so we like building it scale. So and we saw these pictures and we thought, okay, let's take this thrust vectoring propulsion system into an airplane which can also fly aerodynamic. The challenge was really we wanted to fly Vtol, so like hovering, but also go into aerodynamic in the exhibition halls, because everything which we have seen so far during the exhibitions was hovering there, but not really flying.
Yeah.
Not really flying, traditional flight.
So
yeah.
we want really fly and hover in that.
Always a challenging problem, right? To hover and then transition into traditional flight and then back again to hover and land, isn't it?
That's
But
true.
I was just amazed watching that clip, how agile and under control it seems.
But the idea was not to transition. So my real target was not to do any transition. Because on other planes I flew with some stabilisation. You have to switch if you go fast or slow, or if you go into hovering, and you always see the transition. So I wanted to program the plane that we don't need any transition for any flight condition.
Yeah.
Right, fine.
And you don't see it like shaking in the transition, so
yes.
just one smooth, like going into flying.
It was amazingly smooth the whole time. Yeah.
And,
Fantastic.
And I think that is possible. That was the idea, that this is possible if we use thrust vectoring instead of ailerons or rudders, which are sensitive to speed.
All right.
Yeah.
So let's get into what have you got it there in front of you? Maybe you could point out the key components in terms of the power system. So am I right? There are 3 different fans
Yes, that's
on
true.
this.
Yeah.
Yes, so it's a tri-jet. Why we call this? This is why we call this a tri-jet.
Because of the 3 engines or 3 motors, and only 2 of those are like with thrust vectoring, and the front motor is just like for hovering and keep it stable.
And what size are these fans?
It's a 51mm fan, EDF fan, with a 2007 motor powered by a 4S battery with 800 milliamps.
4S 1500 pack.
Yes, exactly.
And how
No,
much flight
800.
time do you get
Yeah,
in total when you're flying around like that?
Yeah, it's an 800 milliamps pack, so 800. And the flight time is indoors, I think it's 3 minutes, and outdoors it's 2.5 with a battery.
Oh, okay.
So
Not
which
bad.
is
Okay.
for our show the
So
normal time. We
So
need.
could you show me the thrust vectoring system?
Yes,
on
maybe
the
I
back?
power on.
Wo willst du?
Ja, schau mich an.
I love the sound effects.
Yeah, that was exactly. So I have here a model to show it exactly what we do, but we can also. So this is the one which goes into the scale tri-jet. So this is now a deep foamed version, really fitting into it, and this is the prototype which was used to develop the software and to test the concept if it's really working.
Right, so that's probably what we should be clear of. Should have said that originally, that what we saw flying at the start of this video, it's a 2D concept to test out the power system and the stabilisation, right, and the thrust vectoring. What you're planning on doing is building a 3D vacuum-formed model that will look like this scale concept that the scale Star Wars concept.
Yeah,
Right?
that's only the prototype of it.
Yeah, but because I'm a lazy programmer, I thought I'd take an EPP plate instead of a 3D nice, a lot of heavy work. So this is just.
You know, it makes a lot of sense to do exactly. Why put a new power system, stabilisation system in something that looks fantastic, only to potentially crash it and ruin it? So you've done the right thing. So sorry, did we see the thrust vectoring?
Not yet, but we come to it now. So
okay, let's do that.
Okay, so in the moment, the servos, so there are 2 servos on the engines, and they control the flap in behind, which directs the airflow down 90 degrees to do the hovering, or also upwards for the forward flight, fast forward flight. operation, that you can have nice rolls without doing a fast roll. I don't know the English word.
Like a barrel roll.
A barrel roll. So I wanted to have a nice rolling. So there is a 30 degrees up thrust possible and 90 degrees down thrust. And here you can see the servo, how the mechanics work going up and down. And yeah, I spent really quite some time to get an efficient system because
a lot of time.
yeah, Chris was designing propellers, and I was trying to do the ducts and to do the thrust vectoring. And finally we came out with a
really decent design, yeah.
A very special design. So it's a small solid flap at the end and some foil between this small flap and the thrust tunnel, and the foil is shaped from the airflow inside of the tube. So it's always a nice round and redirection. So the efficiency is really, really high. So we really get almost the same thrust vertical as horizontal.
Fantastic.
To get that, there is a long hole. When I did the first prototype of that, I thought, oh, you are crazy, man. You should not try this as an engineer because it's not going to work. It will flutter and do its own things. But it turned out to work exactly precise and perfect. So maybe I switch on a little bit the engine so you can see it, because without the airstream, the foil is not nice shaped, of course. So now the engines are running. And when I not sure if you can see it. You can cut a bit out of the noise then.
No, that was fantastic. Thanks for that up-close demo. Right, so that's the power system, the thrust vectoring mechanism.
Yes.
But how about the flight stabilisation? You can't just put that together and expect it to work. There's an element of coordination between all of the different components there. Yeah. So what is the flight stabilisation that controls all of this?
Yes. So we have the engines connected to a all-in-one ESC. So this is the FabTech new 4-in-1 35M ESC going up to 6S. So to save the weight. So it's a really nice ESC. And it's connected here with this wire to the flight controller, which you can see here. And this is a 20mm flight controller, which is basically programmed with iNav. Maybe you know from the copters iNav software, so this is open source. So I was able to do some tuning to it to integrate the thrust vectoring of an airplane into the iNav code. And so we don't use the fixed wing of iNav, so this is always in copter mode. But I majorly changed the motor mixer and the logic behind it to do without transition the airplane.
Alright, so we're getting a bit beyond what your typical aero modeler would do now. You're talking about software, aren't you? And,
yeah,
and writing code.
Yeah, C code to get it more precise.
Oh, no, C code.
Yeah.
I mean, I'm a software engineer by trade, so wow.
Okay.
You're getting quite deep. You're scaring people now if you're writing a C program code. That's fantastic.
It took some time to get behind the math. How do I find the right servo position for a request from the controls?
Complex stuff. I think we get it. It's complicated. All right. So that's the concept, the prototype at the moment.
Exactly.
And what you sent me was a demonstration of the vacu-forming process that you're going to use to construct the 3D model, yes?
Yeah. But before we go to that, maybe I can show you a little bit. I'm going to demonstrate it a little bit more how it works.
Oh, okay. good practice for Leipzig.
So when I can fly it in here, I can fly it also in the exhibition.
You can fly it anywhere. You can fly it in your basement at home.
Yeah, so we put that to the side and go now to the 3D concept.
Yeah, I think, and here's the thing, Dietmar. Yourself and Jürgen and Daniel, you know, who are also members of the DMFV team, who also create fantastic models, like the big Corsair that Jürgen flies, and the other airliners. People are fascinated by how you make them so light. And my understanding is the secret is this vacu-forming process.
Exactly.
And you don't put helium balloons inside these things, it's purely because they are built so light. Am I right?
That's right, yes.
That's right.
Right, okay, so this is what, Chris, this is 2mm Depron, is that right?
Yes, in the beginning we just first have to get a design what we're trying to build. So we are starting at the computer, like in the CAD system, to create like our molds. We make them in 3D printers, and these are just normal FDM 3D printed molds. Some of them are really large, took quite a lot of time to make these. And then we use them to put it on our vacuum forming machine to create like thin sheets of Depron foam. It's like really light, it just, like maybe it flies from
This is 2mm Depron, isn't it? I think traditionally Depron that you can get hold of is kind of the 3 to 6mm Depron that is used to insulate under flooring.
Yes, and we are using this material, then cut it like in the half to get thinner sheets, and use the thinner material to create, like this is only the skin of the model. So
this is half of a sheet. This is 1.5mm Depron.
You actually slice it in half?
Yes, to save money, so we can take 2
How do
pieces.
you do that?
That's also another process. Also very difficult.
Okay.
But these pieces are light but not strong enough. So now we're going to do is like to put a structure underneath it to get like high strength. And so we have a nice skin, like a good like a good surface. And it's also like very strong at the end because of the structure underneath. Yes.
And then colour on top of that. How would you decorate that? Would you use paint or vinyl covering or something like that?
We use different kind of methods. We are going to use also spray cans to the basic coloring, and afterwards with the airbrush gun, like all the details and stuff.
Okay. Amazing. Well, looking forward to the final model. I hope you'll share that with us when that's complete.
Of course.
But otherwise, we're looking forward to seeing it at the Leipzig show, which is in October, isn't it? So let's hope.
Yes, let's keep fingers crossed that we can see our friends all
Fingers
again.
crossed that we all get out of this pandemic, that we all stay fit and well, and that we can all meet up in Leipzig in October. Is there anything else you wanted to share with us about the tri-jet?
Yeah, I mean, we will do the 3D things like the cans. Those are 3D resin printed, and we will use them as they are.
Yeah.
Oh, I see. So these are kind of scale details you're adding on.
Genau.
Cannons, you said. Oh, right, okay. they're lit up with LEDs.
Exactly, so we use the RGB LED function also of iNav of the flight controller, so it's also, this tiny flight controller will also control all the lighting of the aircraft. Like pod racers, this is also common.
Oh, I see. And knowing you guys, you'll be flying to some nice music in the background as well, with the lights turned down.
Yes, that's the plan, exactly.
Should be quite a show. I look forward to it.
Yeah, and this is, for example, is it the canopy or what is?
That's the canopy, yeah.
The canopy.
The canopy on top.
So that's
with
almost
the
finished.
pilot.
Yeah, also with a little pilot inside. Yeah.
Brilliant.
Yes.
I can't imagine the hours that goes into creating something like this. Hundreds, if not thousands of hours, I suspect.
Well, I think with less he's very efficient. Chris is the fastest designer I know, so he does it really fast, the 3D models, and yeah, I mean the printer runs on its own, so when you put it on printing it takes weeks, but you only have to change material.
I got you. Okay, look, let's wrap it up there. Thank you so much for this insight into this new project that you're working on, and again, hope to see you in October for the Hobby Model Spiel trade fair in Leipzig in Germany, like we saw you in 2019. We'll have a few beers and we'll have some fun.
That would be cool, yes.
Exactly.
All right, take care, guys.
Right.
See you soon.
See
Thank
you,
you,
bye.
bye.
Yes.
Yeah.